Well, today I'm going to teach you all the preparation of hydrogen chloride gas, which is symbolically represented as HCl. The formula of hydrogen chloride is HCl. Remember, when HCl is in the gaseous state, when HCl is in the gaseous state, we call it as hydrogen chloride. But if HCl will be dissolved in water, we will call it as hydrochloric acid. That's the difference. So first of all, I am going to teach you about the preparation of hydrogen chloride. The first time the hydrogen chloride was prepared when concentrated sulfuric acid was added on rock salt. It gave hydrogen chloride gas, which is having a choking choking odor, and this is your acidic gas. So why are we choosing concentrated hydrochloric acid? We can use even concentrated nitric acid. The reason is that concentrated sulfuric acid is a non-volatile acid. Non-volatile acid means which will not evaporate or vaporize easily, whose boiling point is very high. And the boiling point of concentrated sulfuric acid is more than 345 degrees Celsius. Whereas concentrated nitric acid is a volatile acid. Volatile means which will evaporate at a low temperature, whose boiling point is low. Nitric acid, the boiling point is around 120 degrees Celsius. The boiling point of nitric acid is 120 degrees Celsius. Means it will start evaporating when the temperature reaches 120. So if you are preparing hydrogen chloride gas by using concentrated nitric acid, then along with the HCl gas, some of the nitric acid will also start vaporizing. It will convert to the gaseous state. And one more problem can arise, that nitric acid, which is unstable to heat, will decompose and form nitrogen dioxide gas. It will form NO2, oxygen gas, and along with that it will produce water vapor also. That's the reason we don't use concentrated nitric acid, we use concentrated sulfuric acid. It's a non-volatile acid. But there is a non-volatile property as well. What is non-volatile property? It is a property by virtue of which a non-volatile acid can displace a more volatile acid from a salt. So here, during the preparation of hydrogen chloride gas, one must keep one thing in mind, that the temperature should not be more than 200 degrees Celsius. We have to maintain the temperature less than 200 degrees Celsius. Yes, less than 200. Otherwise, what will happen? It will form a thick white crust at the bottom of the flask, which will be very difficult to clean after the reaction, and while cleaning, the flask is likely to break. One more problem can arise, that due to the thickness of the crust which is deposited at the bottom, a lot of heat energy is going to be wasted. So if sufficient heat energy will not be imparted, will be supplied to the reactants, the reaction might go passive. And the reaction, it may stop also, it might stop. So that's the reason why we are going to maintain the temperature less than 200 degrees Celsius. So when the temperature, I will be writing both the equations for the temperature below 200 and for the temperature above 200. we are taking sodium chloride, the common salt, and then we use so when the temperature is maintained less than 200 degrees Celsius, then sodium bisulfate will be formed, which will be soluble completely, means it won't be forming any kind of crust, and it will release HCl gas. We're just balancing NH2NaCl plus H2SO4 plus Na2SO4 plus 2HCl. Equation is balanced. Yeah. So because of this formation, when the temperature is more than 200 degrees Celsius, because of the formation of the sodium sulfate, this is only sticking at the bottom of the flask and giving you a thick white crust because of this. Now, that's the reason why that this reaction is discarded. We'll prefer this one. We will make that sure that the temperature is not going above 200 degrees Celsius. Now, I am going to tell you about the lab preparation of hydrogen chloride gas. Lab preparation. For the lab preparation of HCl gas, we have to set up the apparatus. This is a wire gauge. I am providing the wire gauge at the bottom of the flask, so that what will happen? The heat will be evenly supplied to the round bottom flask. Heat will be evenly supplied to the round bottom flask because of the wire gauge. And then this is the wire gauge. Here is the tripod stand. And I am putting the Bunsen burner over here. This is the Bunsen burner. Now, let me first set up the apparatus. This is the ring nut. Okay, so this is the thistle funnel in which we are pouring the concentrated sulfuric acid, conc H2SO4. This is our thistle funnel. This is our thistle funnel. And now in this we have sodium chloride solution. This has sodium chloride, NaCl. Now your apparatus is ready for the preparation of HCl gas, hydrogen chloride gas. So you are pouring the concentrated sulfuric acid from the top through the thistle funnel, and that acid will come and will start reacting with the sodium chloride inside the round bottom flask. Now precaution must be taken that the end of the thistle funnel is dipped inside the sodium chloride solution or inside the reactant. Why? So that the HCl gas which is prepared doesn't escape through this tube. Otherwise HCl will just escape out, will just go out. That's why this end must be dipped inside the solution, inside the reactants. That is, and after that, once the HCl gas is, now the thing is heated, the HCl gas will be produced. Along with the HCl gas, the water vapor will also come out. Because you are heating, there is a water content inside it. So that will also evaporate, and both water vapor and HCl, they will come together. But we need a dry HCl gas. For that we need to remove the water from HCl. So in order to remove the water, we are using a drying agent which is concentrated sulfuric acid. This will be acting as a drying agent. Why concentrated sulfuric acid is used as a drying agent? Because we know that it is hygroscopic. It will absorb the moisture. But what is the property by virtue of it is absorbing? Because concentrated sulfuric acid has a very strong affinity to water. So that's why it will take up the water molecule, retain the water molecule, and will allow only HCl gas to come out. Now hydrogen chloride gas is heavier than air. The vapor density of hydrogen chloride is more than air. So since the density of HCl is more than air, what will happen? It will start sinking down. The HCl will start sinking down. So once it goes down, the air which is at the bottom will be displaced upward. The air which is at the bottom will be displaced upward. That means the method of collection of HCl is by the upward displacement of air. Method of collection is upward displacement of air. We cannot use other drying agents. There are some other drying agents like quicklime, which is calcium oxide. We cannot use. Why? Because calcium oxide is alkaline. It's basic in nature. So that will react with the HCl gas and will form salt and water. Calcium chloride, it will react. Calcium chloride and water. So it will react because calcium oxide is alkaline, basic in nature. That's the reason we are not using other drying agents over here. So this was all about the lab preparation of HCl gas. Hope you liked it. Thank you very much. Please subscribe my channel, like and comment. Please do not forget to comment. Thank you very much.